everyone. So we have been discussing on S parameters and its properties and all those things. So we will continue it further, and I will just start with that where we left in the previous class. So in the previous class, you have seen that what are the four properties of S parameter and how these properties can be used, what is meant by unitary property and all those things. Further moving on with the contents. So we'll understand that what do you mean by the fourth property, that is the phase shift property. Can you see the document?
Yes, sir.
Yes, sir.
Yeah.
Yes, sir.
Okay, so phase shift property is that what we have left in the previous class. So in the phase shift property, you have to see that S parameters we will be using here. These things we have discussed in the previous class. I think you have completed till here. Yes or no? We have discussed all these things in the previous class with the matrix S is equal to S11, S12, S21, and S22. So here what we are going to do here is we are having this one. We can see that, just a minute. You can see that this is the first reference plane, and this reference plane can be shifted. So it is shifted here. So this is one has shifted to 1 dash, and this reference plane has been shifted to this side. So there will be a change in phase difference. So you can just complete it off. If the reference plane 1 and 2 are shifted to 1 dash and 2 dash, the phase difference is generated, that is phi 1 and phi 2. Phi 1 will be beta 1 L1 and phi 2 will be beta 2 L2. So there will be the change in variation with respect to the wave, and you will have A1 E J phi 1, B1 E minus J phi 1, A2 E J phi 2, and B2 E to the power of minus J phi 2. So this is what you're going to get. So the this is the S matrix representation. So with respect to the phase change, we will be just modifying the equation further. So you have completed this section.
Yes, sir.
Okay, so if you have completed, we'll just move on with the equation for that. Yeah, so this is that phase change which you can observe when it is S dash. So this is called as a phase shift property, and where you can see that it is e to the power of minus j phi 1 0 and 0 e to the power of minus j phi 2. This term, this matrix as well as this matrix get involved in it when you consider the phase change. So these two matrices, e to the power of j minus j phi 1, 0, 0, e to the power of minus j phi 2, and matrix S, then you have e to the power of minus j phi 1, 0, 0, and e to the power of minus j phi 2. So this is called as the phase shift property. So you complete it off. Have you completed the phase shift property in the previous class itself, these things?
No, sir.
This thing, if you want to complete it, just complete it fast. So phase shift property is very simple. You are just changing the reference plane. When you change the reference plane, it leads to the change in phase, that is phi 1 and phi 2, and the parameters like a1 b1 and all, it will the variables, wave variables will have the shift in the phase. So we'll have another matrix called as S dash, which is with respect to the change in phase. So that is what we'll be seeing. This portion, if it is completed, I will just move on next slide, next one. You're still writing it? Bhumika, you have completed this or still writing it off?
Writing.
Okay, okay, completed. Once you complete, just let me know that.
Finish.
Yeah, fine. So you can see that change in phase matrix S dash also you can write it. That matrix S dash is called as the phase shift property, or where you are having a change in phase when you change the reference planes. Okay. So you complete it, and then we will move on to the next topic, that is called as S parameter of two-port network with mismatched load. So I'll just explain it, then you can write it. So if it is over, we will just move on with the S parameters of two-port network. So we will just discuss upon the S parameters of two-port network. I think you might have completed it. Is that over? We'll start with the new topic.
Yes, sir.
Okay. S parameters of two-port network. No, just listen here. Anyhow, I have sent you the notes also. You can see that and write. So you can just listen here. I will spend some time for you to note down this as well. So just listen here. So when you are taking a S parameters of a two-port network with mismatched load, this you can see here that we are focusing on the mismatched load. So mismatched load means what? You just imagine that you are having a bigger pipe and you are allowing the water to flow. So then it is you are having one single pipe and you are allowing the water to flow. Then you can say that the it is almost like a match load. But you just imagine that you are having a bigger pipe and then you suddenly switch over to a small one. So there will be lot of disturbance at the junction. So because of the flow is different in both the places. Same way, yeah, when you are using the microwave devices as well, you have two-port network devices when you take. If you are having a change in or discontinuity between the input and output ports, then there will be lead to mismatch of the network. So this is what we will be seeing. A two-port network or a junction formed when discontinuity between the input and output port is there. And here you can see here I have drawn 2 to 3 figures here for you to understand. So this is the waveguide 1 and this is waveguide 2. So you can see that there is a change in change over here from here it is Z characteristic impedance is Z01 and here it is Z02. So there are a lot of changes. So it is like a step it has come, and so it is called as a step junction as well. So when you have this, there will be a lot of mismatch taking place here. So we will be understanding those things, what the parameters will change and how the S matrix will look like, what is the equation it is going to matter when it is a mismatch network. So that is what one of the figure we have drawn here. Here we have taken Z is equal to 0 at this point, at the center. Then here it is Z less than 0 and here it will be Z greater than 0. So if you take another figure where you are just having a coaxial connection, you can just see that a waveguide is placed. So this is the waveguide. This is the waveguide. So in this waveguide, this coaxial connection, you are just dropping a coaxial connection here into the system. So what you can see here is, so when you have a coaxial connection here, so this entire portion you can see that there is some difference it is going to create in the waveguide. So when you are, it is like you are having a plane surface and some box type of thing, and you are inserting something into it. So this is with plane one, and this is with another one too. So when you are doing something different into that box, what it will create, it will disturb the entire thing. So that is what it is going to take place in this microwave setup as well. When you are just having a connection or coaxial or probe into the waveguide, so it is going to have an entire mismatch of the network. So these are some of the figures which explains you how the mismatch takes place in the network. And if there is a mismatch, we are going to see that what difference it is going to create with respect to the means you can say that there will be reflections, and what difference it is going to create in the parameters when you talk about the gamma, or you talk about Z, or you talk about S parameters. So what difference it is going to create when there is a mismatch in the network. So this is what you can see. This is the entire mathematical representation or the equivalent circuit for a mismatched network. It's the same circuit what you can see here, where you have two port networks. This is the input port, and you can say that this is the output port, and this is a two-port network where you have Z0 as the characteristic impedance. So further on, moving with the S parameters, you know that there are four parameters when it is a two-port network, that is S11, S12, S21, and S22. So we'll be just seeing what difference it is going to create when now till now we have been discussing on matched network. So till here we have discussed on matched network, but this topic is basically on mismatched network or mismatched load, where you have the variation in the input and output, or you can say that the discontinuities are there between the input port and output port. So when there is a discontinuity in the input and output, of course the equations of the S parameters like S11, S21, S12, S22, all those things are going to have some change because of the variations, whatever it is there in the network. So that is very important for us to know that how these parameters are going to impact when it is in the case of a mismatched network. So we are going to see all those things. So during the propagation of the microwave through junction, one or the other, the evanescent modes we call are excited. So I have told you that when there is a discontinuity, so of course there will be certain change in energy, and which will lead to, we call it as evanescent modes, decay very fast when it is away from the junction. So you can see that when you are moving the water through a pipe, you can just, I'm just saying an example, and you have a bigger pipe and a smaller pipe, you can see that at the junction there will be lot of energy variations, and you can see that which leads to the evanescent modes, and which further decay after a certain time. Like when you move from the bigger to the smaller, that place it may be having, once the water enters to the small pipe and then it starts moving, then it will flow in that way of that, how that signal also does the same way. When you have a mismatch at that particular junction, you will have some discontinuities, and you will have some evanescent modes which decay very fast for that junction, and it becomes negligible after a certain distance, after you move for a certain distance. This is what it is going to take place in the case of mismatched network. We have to define all these things with respect to the equations. So the further we'll be discussing on how the equations are going to impact when it is a mismatched network, and what impact it is going to create on the parameters like S11, S12, S21, and S22. So this is what we are going to see. You can quickly note down these things fast, and we will continue it further. Okay, you just note down the things faster, because you have the figures. It means all this document I have sent to you before as well, so you can write it down first, and we will continue further. So we are discussing on S parameters of a two-port network with mismatched load. So draw it fast. So we will once you complete it, we will continue further. Next portion is where we are going to talk about the equations and all, so you can simultaneously solve along with us. So just you can write down these things and we'll continue. So once you complete it, just let me know that. So you can just complete it fast. You're doing it, or shall we continue further? You have completed it, then we'll continue further.
Yes, sir.
Yeah. So you can draw all these three figures first. Because I don't want you to just spend some other time as well for this. So you can do it first and we'll continue further. Will get almost we are going to complete 1.5 module for your internals. So another one more class, 1 or 2 classes may be enough to complete whatever syllabus is for your internals, 1.5 module. So we'll be further moving on to the next topics. So all the material what is required for you for internals I have sent you through WhatsApp, and all the documents are also available. Assignments you can solve it and put it in the MS Teams, and you can proceed further. This time internals procedure will be slightly different, so get adjusted to that. So if we have completed this thing, we will just continue further. You need some more time?
Yes, sir.
Okay. So once you complete it, then let me know that we'll proceed further. So here what you have understood here is we are going to go with the mismatch load, and when you are having the mismatch load, you will be having evanescent modes, and that gets excited at the discontinuities, and which will have a certain relative energy, and the evanescent modes decay very fast after a certain distance from the junction and becomes negligible. So that is what in somewhat in the one wavelength range. So that is what it is going to happen. So we will be having slight modifications with respect to equations. Whatever we had studied before is all equations for the matched load, and now this topic is based on the mismatched load. So if you complete it off, just let me know that I will proceed further.
Done, sir.
Okay. So for anyhow, you have that material as well with you. You can, if you have not completed, you can just complete it off. So we have, as we have seen that we are discussing about two-port networks, and as I have told you that there will be energy mismatch at the evanescent nodes, and then further, as and when one wavelength distance is there, it becomes as normal as that. So then further we can see that when you choose the distance that is equivalent voltage and current and all these things, we'll see that there is a total transverse and electric and magnetic fields for this. So we have considered two-port network, and when we have considered two-port network, by normalizing load thing, we have to use this one, that is ZL divided by Z naught, and ZG divided by Z naught, both will be equal to 1. Then the load reflection coefficients we will be writing. So we are going to write a few equations based on the mismatched load. So first we will be starting with gamma. So gamma 2 we will be writing. Gamma 2 we have, if you see here, see, whatever you have studied for the first matched load, it might not be the same as that of when you go with the mismatched load. So here you have studied, if I go back to the previous class, you have studied reflection coefficients, attenuation coefficients, B1 by A1, B2 by A2, and all those things. But this is all for the matched network. But when you go with the mismatched network, it will not be the same. So for mismatch network, we will see that gamma 2 will be written as that is A2 divided by B2, or we have also studied that in terms of ZL and Z0, gamma can be written as ZL minus Z0 divided by ZL plus Z0. So I am just dividing by Z0 in the numerator and denominator. I'll get ZL divided by Z0 minus 1 by ZL by Z0 plus 1. So you complete it till here. Further, it's all equations. You can solve it along with me. So we will be solving it one after the other. So just complete it till here, and then I'll continue with the equations, and then we'll see one how the equations are interrelated. What is gamma 2? What is gamma 1? And all those things for a mismatched network. We are going to study all these things for a mismatched network. It will not be the same as that of the matched network. So you don't get confused with matched network and mismatched networks. The mismatched networks equations, everything will be entirely different. So you will be having for gamma 2, it will be A2 divided by B2, and gamma can also be written as in terms of ZL and Z0 as ZL minus Z0 divided by ZL plus Z0, which you have already studied in the previous class. So the same thing we have used here. So gamma we have written in terms of Z as well as in terms of A and B parameters. So once you are done with that, then we will move with the equations further. So these are all not difficult things to understand, and we have also studied the equation for S parameters. So the equations for S parameters, we are going to use it. You know that matrix B, you know actually that matrix B can be written as matrix B can be written as combination of matrix S into matrix A. So this is what equation we are going to use it. So this equation we are going to use that, and then we are going to solve it further. So you got till here you have completed, means we'll proceed further. Is that done? The equation.
Yes, sir.
Okay. So we have two equations to go ahead with, which you have already studied in matrix, that is S11, S12, S21, and S22. By using this equation, B is equal to matrix S into matrix A. So when you are having this matrix S into matrix A, then you can just see that how best you can write these equations further. So we are going to use this matrix B is equal to matrix S into matrix A and then proceed further. So B1 can be written as S11 A1 plus S12 A2, and B2 can be written as S21 A1 plus S22 A2. These are non-equations for you. So these two equations are not new for you. So these two equations we are making use of it. So B1 can be written as S11A1 plus S12A2. So we are going to just replace this with whatever we have studied here for gamma 2, that is A2 divided by B2. So we will try to just simplify it further. So what you're going to get, let me take the equation number 1 first. So what you're going to have here, B1 is equal to S11A1 plus S12A2. So S11A1 plus S12A2, I have replaced it. This A2 can be replaced it as gamma 2 B2. So I have replaced A2 as gamma 2 B2. So that is what you can see here. A2 is replaced as gamma 2 B2, and I have put that as equation number 1. Then if you go with B2, B2 is S21 A1 plus S22 A2, and here also A2 can be replaced as gamma 2 B2. So I have got equation number 2 as well. So these are all easy things to understand. So the input reflection coefficient, when I talk about gamma 2, I got A2 by B2. But when I have input reflection coefficient is called as gamma 1, and gamma 1 is defined as B1 by A1. This is for mismatch network. We are talking about the mismatch network. Okay, gamma 1 is defined as B1 divided by A1. So you should not get confused with matched and mismatched, and don't mix the equations between matched and mismatched loads. So here, when it is input reflection coefficient, gamma 1 will be equal to B1 divided by A1. So I am just going to rearrange the equations further. I got this equation number 2. So let us make use of this equation number 2 for the further solution. So what we have used is from equation 2, what you're going to get, you can see that you're going to take this equation number 2, that is B2 is equal to S21A1 plus S22B2 gamma 2. So let me take B2 common outside and A1 separate. So I have removed B2 separate here and A1 terms separate here. Then finally I will come out with the equation for B2 as S21A1 divided by 1 minus S1, S22 gamma 2. So I got the equation for B2 as S21A1 divided by 1 minus S22 gamma 2. Is there any doubt till here? It's nothing we have done much rather than using the equations for B and B1 and B2. We have just substituted for gamma 2 is equal to A2 by B2, and we have substituted for A2 as gamma 2 B2. So we simplified it further with the input reflection coefficient is gamma 1, that is B1 by A1, and we took the equation number 2 and separated the B2 terms and A1 terms separate and simplified it further to get B2 is equal to S21 A1 divided by 1 minus S22 gamma 2. So this much is clear for everyone? Is this clear till here, till the equation of B2?
Yes, sir. Yeah. Sir.
Okay. So let us substitute this equation in 1. So what you got this B2, I want you to substitute in equation 1. So let us substitute in equation 1. So we'll get B1. So B1 is equal to, so what you'll get? B1 is equal to S11A1 plus S12, S12 B2 gamma 2 is the equation 1. So this equation, we are going to take it. So I have just written the same equation here. So after that, what I am going to do further is I am having B2 equation for B2. I am having all these things. I will try to substitute those things and simplify it further. So what I should do here is B2 is available for me. So this B2 is available for me. Here B2 is S21 A1 divided by 1 minus S22 gamma 2. So I can try substituting that B2 there. So I have substituted that B2 there, and S11 A1 plus S12 gamma 2 S21 A1 divided by 1 minus S22 gamma 2 when I substitute B2 in that equation. So further we will move on further. So I have substituted here. So further we have gamma 1. Gamma 1 is equal to B1 by A1, which we have studied here. Gamma 1 is B1 by A1. B1 is also known to you. A1 is also we know that. So what you can just write it in very simple form is if you take this is also A1 and this is also A1. So what I can write is gamma 1 is equal to B1 divided by A1, that is equal to S. From this equation you can get it. S11 plus S12 S21 gamma 2 divided by 1 minus S22 gamma 2. I think it is clear for everyone. Have you completed writing it off?
Yes, sir.
Okay. So till gamma 1, it is clear for everyone. Any doubt is there till gamma 1? So we have used the two equations
No, sir.
B1 and B2 and then simplified till gamma 1. So you got the equation for gamma 1. So we will proceed further. So you got the equation for gamma 1 as S11 plus S12 S21 gamma 2 divided by 1 minus S22 gamma 2. For mismatched load, there is a condition we can say that gamma 1 will not be equal to S11. So for reciprocal network, we have Sij is equal to Sji. So using Sij is equal to Sji property, so you can use that property of Sij is equal to Sji, and you can say that S12 can be written as S21. So since I can write S12 as S21, so my gamma 1 can also be written as S11 plus S12, S21 is there. So I can write it as S12 square because my S12 is same as S21 or S21 is same as S12. Anything you can write. So here I have written as S12 square gamma 2 divided by 1 minus S22 gamma 2. So we are just using the properties of S parameters further. So you got gamma 1 in much simplified form as S11 plus S12 square gamma 2 divided by 1 minus S22 gamma 2. For lossless junction, we have studied in the previous properties of lossless junction. We have already studied that summation of n is equal to this equation. We have already studied in property number 3. So what is that? Summation of n is equal to 1 to n, Sni conjugate will be equal to 1, and n is equal to 1 to n, Sni conjugate will be equal to 0. So I am just making it instead of n and I and n, I am just taking it in terms of two-port network, that is S11, S11 conjugate plus S12, S12 conjugate can be written as 1, and S22, S22 conjugate plus S12, S12 conjugate can be written as 1. This I have taken in place of I and n, I am taking it as a two-port network. And also I know that Sij can be written as Sji. So if I have S12 and all, I can also write in terms of S21. Both are correct, since it is a reciprocal network. So till here you complete it, then we'll continue further. Is that over?
Yes, sir.
Okay. So we got gamma 1 equation. We got since it is a reciprocal network, all this Sij can be written as Sji. We have the property 3. We got these two equations. These two equations we got. Still we can write the equations from this. So we will see that further. So we have here Snk Ni conjugate is equal to 0. So from that we can write this equation S11 S12 star is plus S12 S22 conjugate will be equal to 0. So these are all the equations required for us by using the property of S parameter, that is the third property. For a lossless reciprocal two-port network terminated in matched load, this is what you can see here, that S11 is equal to S22. So how this S11 will be equal to S22? If you take the modulus of that, in case of reciprocal network, you can see that S11 is equal to S22. You have these equations here. So S11, S11 conjugate plus S12, S12 conjugate is equal to 0. And you have seen the equations before. S11, S11 conjugate plus S12, S12 conjugate is equal to 1. And all these things. You can also write it as S11 modulus of S11 can be equal to S22 modulus of S22. So we have seen that yes, if you, I am going to take the equation here, S11, S11 conjugate and S12, S12 conjugate. So S11, S11 conjugate and S12, S12 conjugate. So I'm going to use that equation. So S11, S11 conjugate and S12, S12 conjugate can also be written as in we have actually written S11 square in terms of S11, S11 conjugate before. So here in place of reverse also you can write S11, S11 conjugate can also be written as S11 square, and S12, S12 conjugate can be written as modulus of S12 square. So S11 square plus S12 square is equal to 1, or S12 can be written in terms of S11 as S12 is root of 1 minus S11 square modulus of. So we have studied all these equations for reflection coefficient, that is gamma 1 as well. This is the same equation what I had written before. It's not a different equation. Same equation for gamma. That is gamma 1 is equal to S11 plus S12 square root of means gamma 2 divided by 1 minus S22 gamma 2. So this is what you are going to get if you have this equation for S12 as well. So as per your convenience, you can rearrange the equation, whether it is in S11 or it is in S12 or you want in S22. So however you want, you can rearrange the equation for gamma 1 based on all these equations, like S11 is equal to S22, S12 is equal to this. So if you want, you can rearrange the equation for input reflection coefficient. So you got the equations for gamma 1 as well as gamma 2. This is gamma 1, and previously you had written the equation for gamma 2. If you see back, you had written the equation for gamma 2 in terms of Z1 A2 by B2 or ZL minus Z0 by ZL plus Z0. So you have the equations for gamma 1 and gamma 2. So what we can say here is, in case of mismatch load, by measuring gamma 1 and gamma 2 can be 0, -1 and 1. Is simultaneous equations are obtained which can give the S parameters of the reciprocal network. So we can find out all these S parameters of the reciprocal network, like S12, S11 and gamma 1, gamma 2, all these parameters we can find out if any one of the value is known for you. So if gamma 2, if you take it as 0, -1 and 1, then you can subsequently find the rest of the things. So this is what you have for the mismatch network. So what you have to observe here is the equations what you have studied for matched network and mismatched network is entirely different. So you complete it. Is that over? So you can complete it off with till here. Okay, you complete it first. If you have completed, just let me know that. Okay.
Done, sir.
Okay. Thank you all here. We have just completed this much, and we are left out with now comparison between matrix S, matrix Z, and matrix Y matrices. So that we will be discussing in the next class. So that's all for today's class. You can leave the meeting now. Thank you. Thank you for everyone. Thanks. Okay.